This video is going to talk about some different tools that you have for post-processing. So after you finish the setup, you can go to exit out and double click on results to bring up a new window. And so what this does actually, it rotates the 2D pipe a little bit, and you can see it calls this new thing periodic 1. And so that is your new flow area. And so go ahead and click back on the Z-axis to go back to your 2D view. So there are a lot of different ways you can visualize the solution that you've come to. For example, we can add a velocity contour. So click on Insert Contour, Velocity 1, and location is going to be across this periodic 1, which is just the surface area of your 2D pipe. And we're going to look at velocity and apply. And to go ahead and get the full picture of the pipe, we can go double click on default transform and uncheck this instancing info from domain. And we want to apply a reflection about this axis so we can see the whole pipe since it is symmetric. So we'll click ZX plane and apply, and now this is the familiar laminar flow through a pipe, and we can see here that it's dark blue on the edges where there's the no slip boundary condition, and towards the middle you get a faster, greater velocity, so that the average velocity is 1 meter per second through the whole pipe. So another way to visualize velocity is by adding a vector. So go up here, click add a vector, velocity vector. We'll do the same location, and go ahead and click apply, and then uncheck this contour so you can just see the vectors. And now to zoom in on this screen, you use the right mouse or the right mouse button. So click and drag to see this specific area, and you can mess around with the symbol size, apply, so you can get smaller arrows on your velocity vector. So you can click this up here to see the whole pipe again. So just another way of visualizing what your velocity is doing. You can do the same thing with the contours. Pressure contour. It really depends what the problem is, what you're trying to see. See, one other helpful tool is you might want to see a cross section of a specific velocity vectors across a cross section. So to do that, you go up to location. So you have a lot of options here, but for this 2D problem, we're just going to add a line. Call it line 1, and you just define it by 2 points. So we'll do 1 for our x coordinate. We'll just do 2 meters. We'll do 1, and then we'll start at the bottom of the pipe, and then the next one will be 1, and 0.1, so will be at the top of the pipe. Apply, and you can see it adds a line right here. And so now what we can do is go down to the velocity vector, and under location, change it from showing velocity vectors across this whole periodic 1 surface area to just having it shown across line 1. And zoom back in here, and we can change the symbol. The arrow 3D seems to work well for this. And bam, now we have a cross section of fully developed laminar pipe flow. Let's go back out here and add one more line for comparison. So line 2, and this one will be closer to the inlet of the pipe, so we can just do 0.1, 0, 0, 0.1, 0.1, 0. Apply, and now you have this line back here. Go back to the velocity vector, and now we'll hit this these ellipses right here, and we're going to control click on line 2. Okay, apply, and now we have 2 cross sections being displayed. And so you can see here is the not fully developed pipe flow. So it's just beginning and just starting to move toward the center and get faster in the middle. pretty stark comparison to what this looks like. So you can see how this could be a useful tool depending on what you're trying to see. Another way of viewing this data is on a chart, as we always like to do. So if you go up here to the top toolbar and hit chart, and call it chart 1, it's fine. And for the data series, you come down here for the source, and just hit line 1, so it'll just take all the data from that fully developed flow. And on the x-axis, we want to have velocity in the u direction, and y, we will have the axial distance, which is in this case y. Apply, and now we have a nice analytic chart. So here's the middle of the pipe, the center, the axis of rotation, where the flow is fastest, and here is the no-slip boundary condition here. And so, go back to our pipe. So, there's a lot you can do here, and now that you have the solution with analytic answers, you want to be sure that your answers make sense. So in future videos, we'll go over how to check mass conservation and momentum conservation to make sure that those both check out. And you can also check on the discretization error, and just, a couple different tools that we can show you to make sure that you're getting the right answer. And at this point, you should be able to compare your solution to the hand calculations you made at the beginning of the problem and make sure they're ballpark about the same. So that sums up this example, and we'll see you in the future with more complicated problems.